In this tutorial you will learn how to create different types of spiral surfaces in Grasshopper, and we'll cover multiple approaches how you can generate them that can be used as a base geometry for spiral staircases, ramps, landscape design and many other things. Let's get started. Quick announcement guys, if you're interested in a structured step-by-step learning approach with personal one-on-one support 24/7 and homework exercises, feel free to send an application for our Effekt Architects online course and schedule your call with us where you will get more information about that. First link in the description. The course covers various topics like parametric modeling with Grasshopper, fluid form modeling with SAP-D, architectural visualization, animation, presentation techniques and way more things. As we currently have a couple of available spots, I invite you to apply today and grab this golden nugget before it's gone. Before we start with creating spiral curves and spiral surfaces, I will explain you an essential component in the process of making them. The component is called point polar, and it creates point or points based on the origin point that is plugged in the input P. So if we set first point, right click and set one point, and this guy will connect with the P input, then this point represents the origin. XY input represents the angle in radians, and D represents the offset distance from the point. I will skip this for now. So once we have point, we have the offset distance, which is in this case 5.56, and the angle is 0. I created a slider from 0 to 360, so we can use this in degrees, and I will use radians component to convert these values in the radians, and I will plug it here. So we have this point, we have the offset, and we have the angle, which is 0. So it means that the origin point will be moved along 0 degrees 5.56. So this is 5.56, and this is the result. This point is the result. I created a circle just to make it more clear. If I change this slide, you can see how the position of the point is modified based on this angle. But the distance stays the same. If I change the distance, then the point is modified as well. Alright, and the Z input represents another angle in radians. It means if you want to rotate this in Z direction. Let me explain. Here we set the angle, and we have this angle here. Here we set the distance, and it's this one. Because right now this one is 0, if we change this slider, then this point will be moved along the plane based on this direction and Z direction. So these two directions represent the plane of rotation of this point. So if we change this slider, the point will be rotated based on the plane I sketch here. So if we change, let's say, from 0 to 30, this point will be moved for, let's say, 30 degrees along this direction. Still, the distance from the origin point stays 4.64. This angle stays the same, and this angle, it's not 0 anymore, it's 30. Let me change here. You can see if I change this slider, you can see how this point is rotated along this direction. So once again, with this slider we set angle in XY direction. With this slider we set the distance from the origin point, and with this slider we can rotate point based on the angle we set here and Z direction. As I said, this component is essential to understand, and it will be used in all examples in this tutorial. Now I'm going to explain you how to create spiral and helix surface. I will turn off this. Alright, here we have origin point. But in this case, instead of placing one input, we'll create multiple values for the XY input or the angle in XY plane. The angles we can generate from the range component within domain 8 pi to 0, and we'll extract 145 values. So you can see here that we have 145 values within domain 0 to 8 pi. These guys will place in the XY input, and the distance from the origin point will be 10. Let's see what we get. We have multiple points, or we have 155 points on XY plane, but we can see just 30 or 40 of them. This is because they're overlapped to each other, and if we move them along Z direction, for the amplitude of the Z vector, also we will generate multiple different values that will be generated from the range component. The same number of amplitude we will have as we have points, but the distance will be from 0 to 220. So if I connect the panel, you can see that we generated 145 values from 0 to 20. It means that first point will be stay in the same position, next one will be moved along Z direction for 0.138889, and the last point will be moved along Z direction for 20. Alright, if I turn this on, you can see that we generated multiple points. Here we can change the angle. Here we can change the number of points. And here we can change the radius of this spiral. And here we can change the height. Alright, we'll create another spiral. The only difference will be offset distance from the origin point. So one set of points has distance 10, and another set of points has distance 6. And all of them will be moved along a Z direction for the same values as we use here. And I will turn this on, turn this off. And you can see we have two sets of points. If we use component line, we can connect them. And with the loft, we can create helicoid surface. In the next example, I will teach you how we can create conical spiral, and based on that we'll create conical spiral ramp. So I will turn off this, and again we'll start with a point. The only difference from the previous example is that here we'll have multiple values in the offset distance input. So basically we'll connect point with the P. In the XY input we will generate numbers from 0 to 7 pi and 199 steps. It means we'll have 200 values, and you can see in the panel from 0 to 7 pi we generated 200 equally distributed numbers, and these numbers we will place in the XY input. For the offset distance, again we'll create domain, but in this case let's say from 0 to 12, equally distributed 200 numbers as well as we have here. So it's really important to have the same number of values as we have points. These values will place in the D, and once I turn this on, we can see how we generated points distributed in a spiral shape on XY plane. And once we have these points, we'll move them along Z direction. And the amplitude will be multiple different values. Again, we'll use range component. In this case, we'll generate equally distributed numbers within 0 to 18. Same number of divisions as we have points. It means we'll have 200 values, and these numbers will place in the unit Z component. Once I turn this on and connect with the interpolate component, we created conical spiral. The next step is to create a ramp based on this spiral. In order to create that, we need to extract horizontal plane on the curve based on these points. So basically we need to take out curve parameter for each point. That's why we will project 200 points we have here on the curve using curve closest point, and in the output we have T. This is curve parameter at each point. And once we connect T with the horizontal frame component, in the C goes the curve, we can create horizontal frames. Now the next step is to take out y direction of each plane, and using this direction we can create SD line. So that's why we're going to use deconstruct plane in order to extract y direction of each plane, and this direction will connect with the D input of the SD line. Start point will be origin of the plane, and here we set the length line or the width of the ramp. Once we have frames, deconstruct, origin goes in the start, direction will be opposite direction of the Y component, that's why we use reverse, and here we set the length of the line. Once I turn this on, we can see how we generated lines, and based on these lines with the loft component we can create conical spiral ramp. Alright, in the next example I will show you how we can combine polar point and graph mapper. I will turn off this for now. Here we create origin point, here we create angle in radians from 0 to 8 pi, 167 values, and in the D for the offset distance from the origin point we will have different values from 0 to 4 pi. I check here reverse, so if you want to change the direction of the spiral you can either check or uncheck this one. Once we have points in XY plane we can move them along a Z direction, but these values we can generate from the graph mapper. First we'll create a domain from 0 to 1 with the same values as we have points, and then these values we will remap using graph mapper, and these values from the graph mapper from 0 to 1 we will remap to domain from 0.92 to 15.62. I set these two values arbitrarily. You can play with these two sliders and modify the result. Once we generate these values we will create the SD line. This will be the origin point. Lines will be generated along that direction, and here we have its length, and once we have lines we can create the surface. By changing this value you can twist it even more. With this one you can change the radius, and here we can modify the height of these lines. Alright, in the next example we will include input Z in order to create conical spiral surface. Here is the origin point. The angles we can generate from the range component from 0 to 5 pi, 165 values. Here we set offset distance from the origin point, and here we'll set for how much we want to rotate these points. First I will set to 0 and I will turn on this. Basically the result is very similar to the previous result, but if we add a value in the input Z we'll get something different. I create the slider from 0 to 360, and in order to convert degrees into radians I add component radians, and you can see what we'll get. Basically all these points will be rotated by 30 degrees, something like this. So instead of moving them along Z direction as we did in one of the previous examples, we will rotate them with the input Z, and we'll create another one but with a different offset distance from the origin point. So the same origin point, same angles in XY, same Z angle for the rotation, but different offset distance. And we get something like this. You can see that they all rotated for the 30 degrees as these guys. And once we have these two set of points, we can create the lines between them. Once we have the lines, we can create the surface. Something like this. Alright, and here we can change the angle of the conical spiral surface, and here we can create even more rotation. In the next example, we'll make it even more complex. We'll keep using all these 4 inputs, but in between we'll add one more layer of complexity. Basically, values that will be generated for the angle and for the offset distance will be converted into values in the golden ratio. Let me walk you through it. Once we create the origin point, we'll connect with the point of the point polar component. Then we will create the angles. For both of these set of points, we'll use same angles for the xy values. These guys will be generated from the domain 0 to 4 pi, but we'll convert them in the golden ratio values by adding golden ratio component. So these values will connect with n, and with this output goes into xy input to both of these guys. Then we'll rotate them by 20 degrees, and for the distance, for the offset distance, we'll use values for the first one within domain 0 to 13.75. Then these values will be converted with the golden ratio and goes in the input. This is the first set of points. Then for the D input of the another component, values will be from 0 to 686, and then again these values will be converted in the golden ratio values, goes here. This is another set of points. You can see that this one doesn't have Z input. It means that all these points are in the XY plane. Then once we create the line between these two set of points, we can easily create a surface like this. And here we can modify the larger spiral. Here we can twist it even more. Here we can change the degrees of the larger spiral. In the last example for this tutorial, you will learn how to create a spiral used in the project Spiraling Observation Tower designed by Effekt Architects, and we'll focus just on this spiral and how to create this in Grasshopper. If you want full version of this tutorial, how to make this building in Rhino, you can watch our tutorial, the link is in the description. First, we'll create the spiral same as in the first example from this video, using point polar. Offset distance will be 20, Z input will not use, and for the XY angles we'll place the values from 0 to 30 pi generated from the range component, and we have all these 201 points in XY plane. You cannot see all of them because they're overlapped. Now we'll move them along Z direction. These numbers we can get again from the range, from 0 to 40. The same number of values should be the same as the number of points. That's why we use the same slider. Once we have the values, we will place in the unit Z vector and connect them with the move component. I will turn all of this. Once we have the points, we can create a curve. All right. And the next step is to create this kind of shape. And once we have the shape, we will project this curve on this shape. All right. We'll use the same point as we have here to create the center of the circle on XY plane. Then we will move it along Z vector. And this is really important. We'll use the same domain as we use here to move points along Z vector. So the same domain from 0 to 40 and the same number of values. So basically we could just connect this guy here. It will be, the result will be the same. And here we have 201 circle moved along Z direction. Now it's time to scale this middle part in order to create shape like this. We can use Graph Mapper. So the scaling geometry will be the circle, the center point of scaling will be the center of each circle, and the scaling factor we can generate by graph mapper. We need to generate values from 0 to 1, the same number of values as we have points. We'll remap them using graph mapper. In the graph types I use parabola, and these values we will remap to the value 0.37 to 0.84. You can modify this as you want, and these values will place in the scaling factor. So instead of having the same circle radius, we scale them in order to get this kind of shape. Now this step is really important because here we have 201 point and here we have 201 circle. Basically each point has corresponding circle on the same height. That's why we're going to find the closest point of each of these guys on the scaled circles. And for that we are going to use curve closest point. In the P we'll place the points, in the C we'll place scaled circles, and here we have points projected on the circles. If I connect interpolate, you can see that we created the spiral on this form. I will turn out this and this one. So once we have the spiral, we need to create the surface based on this. There are few methods how we can do it. I will choose to use a method with 2-point vector and with SD align. Basically these points will be the start point of the line. The length will define here. Basically the length will be the width of the ramp, and the direction we can generate from the 2-point vector. This is the first point of the 2-point vector, and these are the second point of 2-point vector. I can visualize this with the line component, and these are the vectors, or this will be the direction of these lines. Once we create 2-point vector, this guy will connect with the direction of the SD align. I will turn all of them, and this one. And once we have SD align, we can create the surface. And if you want to add railing, we can extract the edges of this surface. Then we'll sort the edges of the surface based on its length, and then we'll extract two longest. And these two guys will offset along will offset in XY plane with the 0.06 negative values. Then these two curves we will divide with the component divide length in order to create the points, and these points will be origin point of the SD align, direction will be Z, and here we set the dimension of these lines. And also we can move these offset curves for the same values of the length of these lines. Okay, I will turn this off. And now these two set of curves we can connect with the pipe component in order to give them a thickness.